Hello, my name is Yanwu, and today I will be teaching you the basics of web scraping. First, what is web scraping? Web scraping is the automated process of collecting structured web data. It's used by people and businesses that want to make use of the vast amount of publicly available websites to make smarter decisions. What is web scraping used for? Some main uses of web scraping include price monitoring, price intelligence, news monitoring, and market research. It creates a large dataset for you to use. For example, a company might want to use web scraping to search for feedback on their products. An individual might want news related to the stock market. In this video, in order to get started on web scraping, we will first be using a public library called Beautiful Soup. This library takes advantage of the HTML of a website in order to collect data. This is essentially using inspect element on a web page. For this reason, we will be using inspect element on websites in order to collect information on which tags to use. Tags are the formattings of a website. You will be able to see this when you right-click on this website and enable inspect element. You will notice that the web page is broken down into several subsections. This can include titles, headers of different sizes, paragraphs of text, and links. Web scraping relies on the website having different tags. For example, the title of the page should be put as a title for the HTML. Headers should separate paragraphs of text depending on the subject, and so on. Since the title is self-explanatory, we will skip on to the headlines. Headlines are normally used to differentiate and separate large amounts of text under different subjects. For this video, I'll be using a Wikipedia page. In my case, the headlines are formatted to be H3. In HTML, there are different sizes for the headlines that go by different numbers. H1 would be the largest header, H2 would be the second, and H3 would be the smallest. Likely the most important part of a website is the actual text. Paragraphs of text will almost always be under the label P. Later in these slides, I'll be showing you the different labels for each of these paragraphs. Now that we covered the basic tags across the majority of websites, we can cover documentation for Beautiful Soup. There is a massive amount of pre-built methods in the official documentation, but this video will be only covering the most important parts of this library. The link to this presentation and the official Beautiful Soup documentation will be in the description. Two of the most important methods of this library are the find and find all methods. Each has its own use, but both will be used for pretty much any web scraping project. First is the find method. When this method is called on, it'll return the first selected element. This means that if you find the first method of a paragraph, it'll only give you the content of the first paragraph in the form of a string. This may not sound useful, but it is significantly faster than the second method, find all. Find all will find all the elements selected and returns it as a list. This process is usually very slow, especially for bigger websites. This method is useful because it gives you all the elements. To summarize the first method, it should be used to find the first chosen element of the page. This will almost always be summaries. Note that this can also contain other smaller elements such as bolds, italics, normal text, or links. The second method, find all, should be used to catalog all of a specified element. Something to keep in mind is that since the method returns as a list, printing it directly using the method will not be organized. Instead, use a for loop to cycle through each item of the list and print individual items. Finally, classes. Text that you might want may be under a class. For my Wikipedia page, the chapter I was trying to get is under a class named MW headline. You will need to specify the class in order to get these texts. In order to call for a class, you will need to say class underscore equals and the name of the class you found using inspect element. Since Python already has a use for class, the library uses an underscore after class to separate it from creating a class. Now that we have covered the fundamentals of web scraping, I will now be showing you a quick example of how web scraping can be used. Before starting this project, you will first need to have installed the request library, the beautiful soup library, and possibly pip. You will also need to install LXML. There are mainly two versions of Beautiful Soup, version 3 and version 4, and in our case we will use the most updated version, which is version 4. We can start by first importing BS4 from Beautiful Soup. So we can say from BS4 import Beautiful Soup, and then we can also import requests because that'll let us pull the HTML from a website. Also, when pulling requests from a website, keep in mind that you shouldn't overuse this since it might overload their site of the server. Additionally, LXML is a phraser that is commonly paired with Beautiful Soup, and this is done because the HTML for websites is usually very cluttered, unformatted, or incomplete, and having a phraser will clean up the HTML in a readable format and also fill in gaps of the web page. So for example, in the web page I'm going to use, which is just a Wikipedia page, if you right click and go to inspect element, you can see that the CSS and the HTML for a website is very cluttered, and having a phraser will be able to clean this up. The next part of our program should be to collect the link that we are going to use, and we can store it as a form of a variable and in a text format. So to do this, you can say source as a variable name is equal to requests.get, and this will get the HTML, and .text at the end will put it into a text format. So you can put your link here. .text, and then also you can do soup is equal to Beautiful Soup source, comma, LXML, and this will put it into a readable format. From our slides, we learned that you can find all or a single element from the web page. So in our case, let's do find all because we want all the elements from the web page and not just the first one. So in the inspect element, we can say inspect, and every text will be under P. So you can go back and say paragraph is equal to soup.find all and P. And what this will do is in paragraph, it'll store every single paragraph in the form of a list. You can also do the same for different headers. So for example, header 1 will be soup.findAll h1, h2 will be equal to soup.findAll h2, and same for 3. And finally, you can also do title. So the title of the web page can be called the soup.title. So at this point, h1 will be a list full of all the header 1s, h2 will be a list of all the header 2s, h3 will be a list of all the header 3s, and the title will just be a string of the title. At this point, all the headers, all the paragraphs, and all the titles will be saved. So theoretically, you should be able to print h1, h2, or h3 title paragraph. So we can, for example, print the header 2s. And like I said before, this will be very cluttered. But the way you can fix this is to print it as a for loop. So for example, for x in h2, you can print all the x values as a text form. And now it'll be a little bit more organized. And like I said before in the presentation, sometimes P will actually cover many different elements. So for example, in this paragraph, there is a bold, a normal text, bold again, normal text, bold, a hyperlink, and some more normal text. For the purposes of this video, we will be trying to find all the headlines for this webpage. And even though we can use the table of contents that is built into normal Wikipedia pages, for the purposes of this video, we will not be using this. And instead, we will be scrolling through every single class item for example, history, techniques, human copy and paste, and etc. So to start finding each of the headlines, we will first need to go to the inspect element for each of these headers. So first we can right-click on history and click inspect, and this will automatically take you to the correct class. So it looks like history is under the class equals mw-headline. As for techniques, it is also under class equals mw-headline. And same for human copy and paste. So we can generally assume that most of these headlines are under this specific class. At this point, we discovered that all the main topics are under a class called mw-headline. So we can go back and say, and declare a new variable. We can name this main topics is equal to soup.findAll. And we can say from here, class underscore is equal to mw.headline. And at this point, main topics will have all the headlines of the class mw-headline. So if we print this out, we can see that we do get these headlines, but it's quite cluttered. So instead of printing it out directly, we can say, since findAll puts it into a form of a list, we can cycle through each item of the list using a for loop. So we can say for x in main topics, we can print it as a text format. And now, instead of getting this clutter, we will get each of the headlines in a very simplified format. And now we have completed a small program that will web scrape for basic headlines in most Wikipedia pages. If you have any problems setting up either BS4, pip, or so on, or have problems with your own program, you can contact me using the email in the description. The link to the website I used for my own example will be there as well.